What were ancient iron smelting techniques? Have you ever wondered how ancient civilizations transformed raw iron ore into the tools and weapons that shaped their world? Iron smelting was a remarkable process that played a vital role in human history. Let's break down how this fascinating technique worked. Iron smelting involved converting iron ore into a usable metal through a series of careful steps. The process required precise temperature control and specific chemical reactions. Ancient smelters primarily used local iron ores like hematite, siderite, and magnetite. These ores were abundant and easier to access than the copper and tin needed for bronze, which often had to be transported over long distances. The smelting itself typically took place in small furnaces known as bloomeries. These furnaces were simple structures, often made from clay or stone. They were designed to reach the high temperatures needed for smelting iron, usually around 1200 to 1300 degrees Celsius. However, many ancient furnaces struggled to maintain these temperatures consistently, leading to the creation of a spongy mass of iron called a bloom. The chemical reactions involved in smelting were equally important. Iron oxides in the ore were reduced with carbon, usually sourced from charcoal. The high temperatures and carbon monoxide produced during this process helped convert iron oxide into metallic iron. In the field of experimental archaeology, researchers recreate ancient smelting techniques to better understand them. They build bloomeries and conduct smelting experiments using local materials and historical methods. This hands-on approach helps verify theories about how ancient people produced iron and the efficiency of their techniques. For instance, during the Viking Age, smelting in places like Iceland relied on local resources to minimize transportation costs. This method allowed blacksmiths to produce high-quality iron, even in remote areas. The end product of ancient smelting was a bloom, a porous mass of iron mixed with slag. Blacksmiths would then hammer and fold this bloom to remove impurities and consolidate the iron into a more usable form. Over time, iron smelting techniques evolved. The introduction of more advanced furnaces, such as blast furnaces, allowed for mass production of iron. This innovation eventually led to the development of steel, further revolutionizing tool and weapon production. Studying ancient iron smelting techniques through archaeology provides a window into technological advancements, economic systems, and cultural exchanges of the past. By examining the remains of furnaces, tools, and iron artifacts, archaeologists can reconstruct how ancient societies produced and utilized iron, offering a glimpse into their technological capabilities and social structures.